In section 2, we're going to be working with building models for data, but we're working with linear models. So we're going to start by looking at these scatter plots and deciding which ones are linear and which ones are nonlinear. So I know my data points, I don't know, they're not very good dots. They're kind of like shooting stars a little bit. But this scatter plot here, if we were to fit a trend line to it, would not make a straight line. So we would consider it non-linear. This one here, I could make it a line, but it's a better fit for something that would curve like this. So we're going to call that nonlinear. This guy, if I made a trend line, that is definitely linear. So that's what we're looking at this section. This guy looks more like a W-ish kind of a thing. That is nonlinear as well. And then this set here would be linear. Okay, let's work on making a scatter plot with our graphing calculators. I believe we've already done this. So we should have instructions. Oh no, we have instructions coming up on the next page. Okay, so the instructions are going to be on the next page. So we are going to start by, actually, no, we are going to put our data in here eventually. I already have mine in there. So if you want to pause the video and put your data into your graphing calculator, you can do that, or you can do it here in a minute when we look at the instructions on the next page. So what they're wanting us to do is to start by using the first and last data points to create a linear model. So we're going to use this guy here, the Hershey's milk chocolate, and this guy here, the Baby Ruth. So the first data point is the ordered pair 44.28 to 30, and the last is 66.45 to 80. So I'm using the weight of the candy bar as my independent variable and the calories as the dependent. So the number of calories is going to depend on the weight of the candy bar. We will need to find the slope of our line. So slope, remember we subtract the y's for the rise over subtracting the x's for the run. So that is going to be 50, 66.45 minus 44.28, so 22.17, which is about 2.255. And then we are going to make that into the equation for a line by using point slope form. So linear model, we're going to use point slope form. So that will be y minus a y number equals the slope, which is a number, times x minus an x number. And when we do that, we can use either of our ordered pairs. We just pick one of them. So y will stay y minus, it doesn't matter which one you use. I'll just use the second one, equals our slope number, and that's going to be 2.255 times x minus 66.45. So make sure that your x's and y's are getting in the same place, and you're using the same ordered pair for the x and the y coordinate. Then I'll go ahead and distribute here. So I've got y minus 280 equals 2.255x minus 2.25 times 44.28 be 99.8514. Add your 280. So we get y equals 2.255x plus 130.149. So that is our linear model using the first and last data values. Our slope would be the 2.25, and the units for that slope, the units are going to be, remember we did y's over x's. The y's were calories and the x's were grams. So that 2.25 is calories per gram. Okay, we're going to talk more about that as we get further in. So the second part of what we're going to do here is we're going to use a graphing calculator to create a scatter plot, find and graph the line of best fit, and make predictions. So I'm going to give you all the instructions for that. Okay. One of the first things we're going to need to do is store the data. And to store the data, we're going to be using the stat menu. So that is a button that we push. Stat is a button. So I'll put that in a box. So we push the stat button right there. Stat. And we need to choose number 1, edit. So you can either hit enter or the number 1, and that will bring you into these lists. So mine are labeled L1, L2, L3, L4, L5. If you're missing any lists, they're pretty easy to put back in. Just come see me and I can help you with that. And then we're always going to put our independent values into L1. The independent values are the X values. And our dependent values into L2, those are our Y values. So that when we graph, list 1 is going to go along the X axis here, and list 2 is going to go along the Y axis. So in our problem, we had grams for a candy bar and calories on the Y. Now, if we need to clear a list, like I already did this because I typed my numbers in. So like I had other numbers in my list. So to clear a list, you're going to arrow up to the name of the list all the way up to the top. And then we're going to push the clear button right here, clear, and then arrow back down. Now, if you arrow up and hit delete, that list is gone. I'll show you how to get a list back. You're going to do second insert. So second insert, and then I tell it the name of my list, which was L3. To get L3, I have to do second number 3, and that's going to rename my list L3 and restore that list. But anyway, to clear a list, you need to push the clear button, not the delete button. Okay. Then in order for us to set up and view the scatter plot, we're going to need to use the stat plot menu, which is above y equals. So to access that menu, we're going to push the second button and then y equals. So we'll go second y equals, takes us to stat plot. And I'll just use plot 1. So I'm going to push enter to get into plot 1. And we want to turn the plot on. So this right now it's highlighted to be off. So I want to highlight it to be on. So I hit enter when I'm on. And then you can see that it's going to stay highlighted when I move off it. Then we're going to choose the top left icon. That top left icon, mine is only having 1 row right now, but sometimes there's more than 1 row. And what that looks like is it kind of looks like a little scatter plot. It looks like that sort of. So that's the icon we want to choose. And then you want your X list to have whatever you have wherever you stored it. So we stored ours in L1. We stored our Y list in L2. You can change that though. Like if I was working and I wanted to use L4 and L5, I can sure do that. So in order for me to change that, I can change this X list to like L4 by doing second, the number 4, and then I can access other lists. But to change it back to L1, I do second and the number 1, and that will give me L1. So second and the number 1 gives me L1, second and the number 2 gives me L2. And then for the mark, I usually choose the Cheerio. It seems to show up better. That one, I call it a Cheerio. It's like a little circle. It tends to show up, or donut, or whatever you want to call it. It shows up better than any of the other ones, I think. And if you have a color calculator, you can change the color. Okay, so we're going to quit that menu because we have it all done with what we want. Then, now that our stat plot is turned on, the calculator can automatically fit the window for us. So to do that, we have to push the zoom button, which is in this top row, and then we want to choose option number 9, zoom stat. To do that, you can either push the number 9 or you can arrow down to the 9 and then hit enter. Either thing will work. And there's my scatter plot. It's not going to have the line on it yet because we haven't calculated that, but it does have our scatter plot. If you adjust the window yourself, like if you need to change it, like say I wanted to see a little bit more to the right, I can do that. I can go to my window and I can change my X max to something else, like 75 or whatever. But then I don't want to push zoom 9 again. If I adjust the window, I'm going to want to push the graph button. Otherwise, it's going to readjust to the window that it just had. So like anytime you hit zoom 9, it's going to fit it back to that original window that it had done. So any window adjustments that you make manually to get back to the graph, push graph. Okay. To find that regression line and have it graphed, we need to do the stat menu. All of our stuff for regression happens in that stat menu. So stat. And this time we're going to arrow over to calculate. Now there's different types of regression. We're going to be doing linear regression, which is choice number 4. But there's also quadratic regression that makes parabolas, cubic regression that makes cubics, quartic regression. This is another line, but this one puts like y equals b plus mx. This one does y equals mx plus b. Natural log regression, there's even more. Like there's a lot of options in this menu. But we are just going to be doing option number 4, linear regression. Then it's going to ask me, well, where is your X list stored and where is your Y list stored? So again, I will tell it where my lists are stored. It already has L1 and L2, so I'm set on that. And then we don't worry about frequency lists. That's if you have grouped data, which we do not have. And then we're going to store the regression equation. So to store the regression equation, there's a couple of ways to do this. We can arrow over to y bars and then choose number 1 function and number 1 y1. But there's also a shortcut. I think I could be wrong on this. If I'm wrong, we'll go back and fix it. I think it's alpha trace. So if I go alpha trace, yes, that's it. Alpha trace, then I can choose y1 right away. So we can do, I'll show you both ways. So alpha, which is the green button on mine, and then trace, and then choose option number 1 for y1. Or let me delete that out of there and do it the other way. Vars, which is this button right here, VARS, and then arrow over to y bars, and then choose number 1 for function and number 1 for y1. Either way is going to get you that y1. And then we have to calculate. So we need to arrow down and push enter on calculate. Okay. It's going to give me this screen. It's going to tell me y equals ax plus b. Then it tells me what a is, what b is, and what r squared and r are. And we use those values of a and b to write our equation. So our equation would be y equals 2.88, I'm just going to round, 2.884x plus 97.587 would be how that rounds. And then we can push the graph button to see that on our screen with our scatter plot. So graph, now we have our scatter plot and our line. And if you go to y equals, you'll see your equation is stored in there for you. Okay. So let's talk about what R is. And then we're going to use our equation to make some predictions. R is called the correlation coefficient. It measures two things. It measures the strength and the direction of the linear relationship. Let's see. R can be anything between -1 and +1. So when R is close to 1 or -1, that's the strongest relationship. But when R is close to 0, there is little to no relationship. There's a typing error. When R is close to 1 or -1, there is a nearly perfect linear relationship. A positive R value means a positive slope. So we would interpret that as saying that as x increases, so does y. A negative R means a negative slope. So we would interpret that by saying as x, we need an x there. As x increases, y decreases. Okay. So for our candy bar data, remember we had that equation, y equals 2.884x plus 97.587. And then our correlation coefficient was 0.952. So R equals 0.952. We'll see this more in stats next semester, but basically that tells you that 95% of the 95% of the data is accounted for by the model. So what does R mean? Well, remember up here we said the closer to R is, the better the relationship. And if it's a positive R value, that means we have a positive slope. So interpreting R. So let's write down what we know. Okay, whatever. Since it is a positive value close to 1, there is a strong positive relationship. But interpreting that in terms of our problem, we would say, since it's positive, we would say, as the weight of the candy bar increases, that's the x value, so remember we said as x increases, so does y. So as x, which is the weight of the candy bar, increases, so does y, which is the number of calories. What about slope? Interpreting slope. The slope was 2.884. So remember that slope is the change in y's divided by the change in x's. So in our problem, the y's were calories and the x's were grams, or weight of the chocolate, of candy bar, I guess. So calories and grams. So with our slope of 2.884 over 1, that would be 2.884 calories in 1 gram. So that means for every 1 gram of change in weight of the candy bar, the calories, the total calories increases by 2.884. So let's say, oh goodness, for each, let's say increase, for each increase of 1 gram of weight of the candy bar, the total calories increase by 2.884 calories. And then we have the y-intercept. The y-intercept is the ordered pair that is 0, comma, a number. So 0, comma, a number. In our case, our ordered pair for a y-intercept was 0, 97.587, based on the equation for the line. And again, remember that the x values were the weight of the candy bar in grams, and the y value was the number of calories in the candy bar. Okay, can't spell. We got this. Number of calories. So what this is telling us is that if we have a candy bar that weighs 0 grams, it would have 97.587 calories. I'm not sure that makes sense. So let's talk a little bit about that. So when we're creating these models, they are based on a set of data values. So ours were based on these data values. Our data values ranged in between 39.52 and 66.45. So when we're creating our model, we're just using a very narrow range of weights for our candy bars. So if we go very far outside of that range, say to 0 grams, then the model may not be a good fit for that data anymore. Or if we went like super far out the other way, like 200 grams, this model may not be a very good fit for our data. That's called, by the way, it's called interpolation when you're going in between your data values. It's called extrapolation when you're moving beyond your data range. So we want to be able to use our model to make predictions. That's the whole reason that we do this modeling. So we can forecast the weather or predict how many items to produce for our company so that we're not producing too many or too few to keep up with the supply, or with the demand rather. So there's 2 types of ways that we might want to make a prediction. The first way that we might want to make a prediction is if we want to predict a y value given an x value. So if we're given an x value to predict a y value, then all we need to do is sub in for x and solve for y. We could do this on our calculator, but it's actually just as easy to do this algebraically. So in our problem, if we had an 88 gram candy bar we would just plug 88 in for x. And then work through on our calculator. Oops, 2.884 times 88 plus 97.587. So that is going to be 351.379 calories. If we are given a y value, then we're just going to sub in for y and solve for x. So in that case, what is the weight of a 307 calorie candy bar? So we'll put 307 for our calories equals 2.884x plus 97.587. And solve from there. So subtract your 97.587. That's 209.413. And then divide both sides by 2.884. So we get 72.612. So that would be 72.612 grams. Okay. Now you can also do both of those in your calculator using the model. So if I go to my graph, if I'm given an x value, I can do second calc, and then number one value. And then I can type in the x value, which was 88. Oh, guess what? I have to make sure that's in my window range because my x max only went up to 75. And I may have to adjust my window again. So I can calculate value, x is 88. Oh, there we go. If x is 88, y is, oh, it's not, what's it doing? It's not working. Here we go. X is 88, y1. There we go, 351.34461. So the difference in between the answer that we got on the calculator and the answer I got here is because we rounded our slope and our y-intercept. So it's close, but it's not going to be exactly the same. So this is probably what they're having you do in my math lab. Then to figure out for the 307 calorie candy bar, I'm going to make sure my window goes up. It does not, so I'm going to make my window go up to like maybe 320 or so. Go back to my graph. And then I'm going to have to graph y equals 307 and then find the intersection. So graph y equals 307. When I go back to that graph, I can see that right there is where my two lines cross. So second calc, find the intersection, number 5. And then look for that intersection point. So that is at 72.621863 for the x value, 307 for the y value. So again, the rounding is due to my abbreviated values on my equation. So if your calculator gives you any trouble, send me an email or wait until I see you in class.